completing the square. So completing the square means you have, say, a quadratic. And you want to put the x squared and the x term into a bracket of x plus some number squared. And then you probably would have some number at the back. You would probably add something or minus something, right? But that doesn't really matter. Okay, so completing a square means you want to form this square. So turn out one of the easier way of doing completing a square would be you kind of have to memorize the following. So what you do is, after the x squared and the x term, you're gonna add something. Okay, you keep the constant term at the back, but you would kind of add something by yourself. But if you suddenly add something, then you have changed the expression, right? So you add something and then take the same thing away. Okay, the thing that you're gonna add would be the number in front of x divided by 2 squared. Okay, so here 6 divided by 2 is 3, so you will add 3 squared and then take the same thing away. Okay. And then it would just so happen that this would become a perfect square. Okay. In fact, it will be x plus 3 squared. Okay, so I don't think hopefully it's not too hard to memorize. Like the x squared becomes x and the 3 squared becomes 3. Okay, now this is true simply because if you try to expand x plus 3 whole squared, then it's x plus 3 times x plus 3, then you have x times x is x squared, then 3 times x is 3x, and then x times 3 is also 3x, and then 3 times 3 is 3 squared, and so it becomes x squared plus 6x plus 3 squared, which is what we had on top. So to turn out this always work. And then you would just organize the rest of the numbers. So you minus 3 squared, so minus 9, minus 7, and you add them up. Minus 9 minus 7 is minus 16. And that's completing the square. Now let's try one more. X squared plus 10x plus 8 maybe. If you want, you can pause the video now to try. If not, I'll do it. So we add a square and then take it away. The square we add would be half of this number, so it's 5 squared, and then take it away, and then add the n number. And this would collapse to the perfect square of x plus 5 squared and minus the rest. Now let's try one with a minus in the middle. Turn out if there is a minus in front of x, you pretty much do the same thing, so you just keep going. Turn out you will still add though. You will still add this number divided by 2 squared. Negative 8 divided by 2 is negative 4. So technically you add negative 4 whole square. But negative 4 whole square is the same as 4 square. Right, so turn out this negative doesn't change much. The only difference is when you collapse this perfect square, it becomes a minus in the middle. Okay, so this minus would go into here, but it doesn't affect this. Okay, you will still be adding 4 square. The rest would be similar. Okay, again, completing a square actually get harder when you have a number in front of the x square. If there is a number in front of the x square, you will have to factor out the number first. Now usually we'll ignore the last number, so we'll only factor out the 2 from the first 2 terms. So take out a 2, so it's x squared minus 6x plus 7 would be left outside the bracket. And then you do the same process inside this square bracket. All right, same process as in you add a number and then take it away, but everything happens inside the square bracket. Okay, the number that we should add should be 3 squared, right? Because 6 divided by 2 is 3. Then this collapses into x minus 3 bracket square is a minus because of this. And then minus 2 squared is 9. The complication would then be you have to expand this 2 back in. So it becomes 2 times of the square minus 18. And then you add this 2 up. Let's try one more. So this time we have a negative in front of the x squared, so we'll still need to factor it out. Okay, you want to pause the video, give it a try. Answer is coming 3, 2, 1. So you take out the negative, so it becomes a plus 12x. Leave the 8 outside. Then we add a number, take away a number inside the square bracket. The number we'll add will be 6 squared, and take away 6 squared. Then it collapses into a perfect square. 6 squared is 36. Then expanding the negative. Okay, the very last thing that I want to mention is why do we do this? The main use of completing a square is to find the vertex of the quadratic graph. So you can imagine if this is a quadratic function, then quadratic either look like this or this in the graph, depending on if the starting number is positive or negative. If the starting number is positive, you have something like this. If it's negative, it's like this. But either case, you have a tip, right? Like we technically call it a turning point or a vertex, the vertex of a quadratic. Completing a square actually tells you the coordinate of the vertex. For example, if after completing the square you get this, then the coordinate of the vertex, right, x, y, right? The x coordinate would be the number after x, but you have to flip the sign. So if we see positive 6 there, then the x coordinate of the vertex is negative 6. Y coordinate would be the back number, just copy. Okay. And so, for example, the vertex of this quadratic would have been 3, negative 11. Right, turn out the number in front doesn't affect the vertex. For example, for this, it will be 4 minus 8. Now, obviously, you want to practice this more. You can find some more practice in the membership section where I put in some leveled exercise for you to practice.